All right, welcome to another lesson on methods. This one's going to kind of summarize a few of the things we've been learning so far about methods. First thing I got is a warm-up question for you. So remember, the idea of a method is it's just a small piece of code that performs a specific task. So this one's going to calculate the percentage based on how many points you earned and the total points on the test. So you can see the heading down here. It returns a double, takes in two doubles, and just divides the points you earn by the total points and times it by 100 to make it into a percent. And so you have to figure out how would you use this, right? If this is already coded up for you, how would you use it in main? So pause the video and give it a shot. All right, so basically you're going to call the name of the method. And actually, I should do this first. It returns a double right here. So I'm going to do double percent. Maybe I'll make this a little bigger. And then call the method. So calculate percent. All right, and then pass in how many points I got, comma, and then how many points there were total, end parenthesis, and then a semicolon. So what this line will do is it'll actually call the method, pass in 8 and 10 to these, divide them, crunch, 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 do the math, and then return it in percent. And then usually up here you would do something with it like system.out_print or something. Okay, so we'd actually just print out whatever we got for a percent, right? And I think that represents really the hard part is like passing in the variables and getting them back. But I encourage you to think of a method in that sense, like an input-output machine. Like you pass in, like to do the percent, you'd need to know these two things. You need to know the total points and how many you got right in order to calculate it, right? And it returns that value. Okay, so our overall goal is to keep using methods. It's just another building block that lets us make more complex programs. Okay, so I have a few notes here that we just didn't get to in the other videos. You can have as many inputs as you want. In fact, you could have anywhere from 0 to, I don't know, maybe 100. I'm not sure if there's a limit, but anywhere from 0 to usually about 10 is maybe the most I've ever seen. But you can only have one return value, right? It can be void actually, but that would have no return, but it can't have more than one. It can either have 0 or 1. All right, that's what I just said. Return value is not required. One weird part is that if you do type return, the code will end at that point. So sometimes that's preferable. Like if you were say search to see if a word existed in a paragraph, you might look through the paragraph word by word, but once you find it, you could just return and then you wouldn't want to search anymore. Like you could return true, we found it, and then don't search anymore. So return statement can actually end the code execution in the method, which is sometimes preferable. And then usually like these classes, right, that we make, public class, I don't know why I put static. I guess math is a specific type of class called static, but basically when you do the public class, whatever, then you have tons of little methods inside of there, right? And that's the idea, is that our programs, like a class file, is made up of a bunch of little methods, little pieces to perform a big task. Okay, so the real benefits of methods, I can't stress this enough, that we shouldn't be writing giant mains. Actually, I used to work with this guy that did that, and it was nuts. His code was impossible to read, and it was very wasteful and inefficient in a lot of ways. So one of the real powers of methods is you can just reuse it. So somebody already wrote math.pow or math.random, or the one that scans for int, so we don't have to reuse it, right? And this is really powerful part of Java is there's all these things that already exist, like pop-up windows or a file chooser where you choose a file. So you can actually make a file chooser in Java in like one line of code. And the reason is you're using somebody else's code and you're just calling that method that creates the file chooser dialog, and boom, you've got it. Right, so it's super powerful ideas that you're reusing other people's code, and then you can build on what they've already created, right? Which is, I think, a really powerful use. It also makes it easier to read the code. So like to break it down into little pieces, you can like understand what each piece is doing. Even if you don't understand the underlying parts of the method, like I don't actually know how a scanner scans the input. I don't know how it does that, but I can just call it, and as long as I understand what its meaning, or how to use it, then I can get the scan, right? So I like to think of it as the code is easy. Like this, almost I think a non-coder could understand that what this code is doing is finding the sum of A, B, and C, right? So to me, if you name your methods in a way that's smart, it makes the code easier to read. Um, and then the final one is, they call this modularity, but if you break it into little steps, little methods that each do one piece, that's going to be a lot easier way than coding it, trying to code it all at once. So when I think about like trying to make a video game, that like boggles my mind because it's just too much. But I think the idea is I can start simple and just do like, okay, maybe I want to make my little dude move up, right? So maybe I make a method that makes him move up, and then I have different methods that move them different directions, like down. All right. So basically I can break my task into little tasks, like, oh, I need to load the image, I need to display the character, I need to remove the character, right? So if you break it down into little pieces and code each piece, it becomes a lot less daunting of a task, right? So I think that when we program, that's going to be the key, is to try to break it down into little pieces. And that's actually what we're going to start doing next in this lesson, is I want to do the Pythagorean theorem just broken down into little methods. All right. And before I get to that, actually, I have one other real quick example for you. All right. So what we have here is Tyson's favorite song. It's his Baby by Justin Bieber. Also a big fan. So here's the lyrics to it. Okay. Kind of long, right? Actually, there's more lyrics. Okay. So there's tons of lyrics, right? Um, but they're kind of repetitive, right? And so if we wanted to print out these lyrics, right, we could do a system.out print of every single one of these lines, right? And that would be a whole bunch of lines of code, and it would be a lot of work, all right? But the power of methods is we could break it down into little pieces. Like this is verse 1, I think, and then this is the chorus next, and then here comes verse 2, and then the chorus again, okay, and then verse 3, and then the chorus again, right? And then I'm not sure what this is, like an outro or something like that. Okay, so the idea, especially like with this chorus, since this is the exact same stuff, right, multiple times, we can just make one method that says, hey, put out the lyrics to the chorus, and then we can call it, I think 3 times, because they do the chorus once here, again here, and then another time here, right? So basically what we could do is break it down into little pieces, and I actually have done this because I like this song so much. So basically my main, then instead of having all those lines of code, it just says do the verse 1 chorus, then verse 2, then do the chorus again, so I don't have to retype all the lines. I can just call my method again, then do verse 3, then do the chorus again, and then do that outro at the end. Okay, so by doing this, we can get, here we go, here's the lyrics to Baby. All right, and it's to me, again, this demonstrates the power of methods, right? This is super readable, right? I can tell what's going on. It also saves having to type, where's the chorus? I don't have to type this out a bunch of times, so I can reuse the code, all right? And then it also is very modular, like I've broken it into little pieces so that, maybe we want to change verse 4. Well, I know right where to go, right? I can just jump on down into verse 4 and change it. And it looks like verse 4, actually, I did a for loop because this code was the same. So I made another little method here that was the yeah, yeah, yeah lyrics and just did it 3 times, right, with the loop. So I don't have to type it out a bunch, right? But again, it's modular. So if we want to change it, we can change, just change this verse if you want to sing different lyrics. Maybe some good lyrics for a change. I'm just kidding. I like Justin Bieber. Never mind. All right. Final piece of this, again, too, that's the power of this, is if we did it if we had typed out the chorus 3 different times, right, and then we want to change the lyrics to it, we'd have to change it in 3 spots, right? But another benefit of method is now that I have it in one spot, if I want to change the chorus, right, and I want to say at the start of the chorus, Canada rocks, I can just change it once, and then when we sing the song, there'll be a Canada rocks at the start of every chorus. Okay, there's Canada rocks. There it is, right? So instead of having to change it in 3 different spots, because I have one method that does the chorus, I change it once and it changes it all over. Okay, so I can't stress that enough. Is like we could have made one giant main with this, but there's so many benefits to breaking into methods, right? And that's what we're going to be working on next. All right, thank you for watching.